Hello guys and welcome to our sessions on artificial intelligence. So in the previous sessions we just had our discussions about our regressions as well as our classification problems. So in the regression domain we just saw the example of linear regression, and when it comes to classification we just saw some examples of logistic and k nearest neighbors algorithm. Coming on to the clustering part, so what is clustering and how does actually clustering work is very important to understand. So before that we need to understand the concept of supervised and unsupervised learning. So this will give you a better idea of how actually machine learning is divided into. So we have our supervised learning that consists of classification and regression problems. So then we have our unsupervised learning which has the clustering part. So what is supervised learning? You already know that in supervised learning, you already know what is the output that you need. So you're just classifying, you're categorizing your data based upon the respective output that you need. So that is what you call supervised learning. But unsupervised learning, it is very simple to understand. You don't have any specific output that is given to you in the data. You just manually compare each and every data and see which class it belongs to and then classify the data into separate parts. So that is how your unsupervised learning is working. So very important to understand the difference between your supervised and unsupervised learning. In supervised learning algorithms, we just saw two parts. In supervised learning, we had two parts. That is nothing but classification and regression. So classification is very simple. You are classifying the data into two parts. That is nothing but you have your data that is split into different classes, either good or bad, or spam email or non-spam email, male or female, pass or fail, or different categories of data. You're classifying your information using your classification algorithms in the supervised learning algorithm. So then we have our regression algorithm. So what we saw in regression was, if we know the previous values of some data and if we are plotting a graph, so then we can depict or then we can find out what will be the future values at any given point of time or the respective graph. So very important to understand this. This regression problem is helping you find out the future values. Classification problem is helping you to classify the data into different groups. But all this come under the concept of your supervised learning algorithms. But in unsupervised learning algorithms, so you have a concept called as clustering. So what do you mean by cluster? So you can see here in unsupervised learning where your data is formed into different clusters. So you, by the definition of unsupervised learning, you know that you don't know what is the output, but just by taking in all the information that you have, just by seeing your data or data set, you are able to make some groups. So this different groups that are being formed is called cluster. So cluster will play a very important role in unsupervised learning. So the whole concept of unsupervised learning is like formed by doing clusters or forming clusters with different data. So you have different data, you are manually trying to gain some information about the data and you are manually trying to fit that data into different clusters. So this is very important. The whole concept of unsupervised learning is in the form of cluster. So the algorithm that we will be discussing in now is an unsupervised learning algorithm, and is basically a clustering algorithm. So we call the clustering algorithm as k-means clustering. So what is k-means clustering and how does this k-means clustering really help us is pretty simple. So what does this k-means clustering algorithm mean and how can we form effective clusters using the k-means clustering algorithm? So before understanding the mathematical term for k-means clustering, let us see how we can cluster our data and get valuable information from it. So why do we need clustering, or how does clustering help us is nothing but grouping. So when you group some people into different categories, or when you group some objects into different categories, the amount of information or the amount of knowledge that you can gain from the grouping is very important and it is very valuable as well. So what we can do now is take this example for insurance. So in insurance industry, our k-means clustering as well as our clustering algorithms are playing a huge role because they are helping the insurance industries classify the data into very important parts so that they can monitor the data as well as monetize the data. So making money from the data as well as classifying the data, so monitoring whether the data is correct or not. So what is the first thing that we can try to do is pretty simple. So we'll understand from this example. So the first thing is called as an age column. So you have this column called as age. So using age column, what you can do here. So using this age column, you can find out the ages. So 19, 18, 28, 30, 32. So how we can form clusters here is pretty simple. So you can form a age cluster between that is nothing but below minors as well as majors. Below 18 is one cluster, above 18 is another cluster. So then you can form a cluster based upon the age, that is nothing but seniority. If the person is greater than 60 years, that is one cluster, that is senior citizen cluster. Less than 60, that is another cluster, non-senior citizen cluster. In sex also you can do two clusters, one is male and female, so you can cluster the people into male and female. So you can do multiple clusters. So it is like people belonging to senior citizen category and having the gender as male. So that kind of clusters can also be done. So then number of children, so people who have children, people who have 0 children, 1 children, 2 children, so like that you can also form clusters. Smokers, whether he is a smoker or not, yes or no, that is also forming a clusters. And even regions and charges. So millions of clusters can be formed. So what is helping us in forming these clusters, or how can we use this in our particular program, or how can we get information is nothing but by using this machine learning clustering algorithms, you can get in a lot of data that is forming into different clusters, and you can tell your client that this is the whole distribution of your information. This is how your information is getting distributed into different categories. In those different categories also you have so much of data that can be manipulated. So it is a very beautiful and very important algorithm when it comes to analytics and as well as your insurance. So clustering is one of the most important topics that machine learning engineers as well as data scientists need to know. This is very important, guys. So to look into the mathematical form of our algorithm. So the algorithm that we'll be doing is nothing but our k-means clustering. So what is this k and what does this means in clustering, we'll try to understand. So the algorithm that we'll be dealing with is called k-means clustering. So k-means clustering is nothing but a clustering algorithm that is an unsupervised algorithm. So to understand k-means clustering, so what we'll do is pretty simple. So we'll consider a straight line. So this is a straight line. So we have random points here. So what is the random points that we have is nothing but some random points of data. We have it here. Yeah. So now we have a data distribution of different points here. So we have around 6 plus 2, 8 points are there now. So what we'll do now is we'll try to cluster them. So how do we cluster them? So starting with the k-means clustering algorithm. So the step number of or the step 1 of k-means clustering is pretty simple. Choose the value of k. So what is k? K is nothing but the number of clusters you need in the particular data. So how many clusters are you willing to form, or how many clusters should be formed? So how do you detect the value of k is the next question. So how do you see which value of k suits you is the next question. But to understand which value of k suits you first, you need to understand the working of the k-means clustering. So suppose I choose the value of k is equal to 3. So now I have chosen the value of k is equal to 3. So k is equal to 3 is telling that you need to form 3 clusters. So how do I start with this? So step number 1 is choosing the value. So how many clusters you want? So I need 3 clusters. So the next thing is put 3 random data points. So what is the 3 random data points is nothing but you need to put 3 points on your data. So what is that? Inside your data you are putting 3 random points, because since you have chosen the number of clusters is equal to 3, so you need to put in 3 cluster centers. So 3 cluster centers can be anywhere. So it is not it is not a convention, or it is not a rule that you need to place it in the center only. It can be any 3 points on this line. So any 3 points on this line can be chosen as cluster point. So with this we have chosen the green colored circle as one cluster point. So we'll choose another circle as our cluster point as well. So this is another cluster point. So this will be blue. So the second, it is a blue colored cluster. So this is the second one. So then I have the third cluster point. So what is my cluster point? That will be red colored cluster point. So this is the third cluster point I am choosing. So what are these? These are nothing but the cluster center. So how to choose cluster centers? There are just 3 random points. So any 3 random points you can choose and you can place it. Okay. So now the step number 3. So you have chosen the 3 points. Step number 3 is calculating the distance. You need to calculate the distance. So what is the distance you have? So we'll consider this first black colored circle. So we need to calculate the distance. How do I calculate the distance? So it is nothing but the distance between my cluster point and this particular figure. So this is the distance that I have. The same thing you need to calculate with your other cluster centers as well. So this is the second distance. So the third distance also you need to calculate. So you can calculate the third distance as well. So this is the three distances you have. Now you need to compare the distances and find out which is the least. So as you can see with your naked eye, this green colored, the cluster point or cluster center is the nearest. So what we will do is, we will try to, this black colored circle will become the part of your green colored cluster. So now you can see that our black colored circle became our green circle because the distance was nearest. So this is how you try to form clusters. So start forming clusters by calculating the distance from each point to the other cluster centers. So then you start finding out the distances and you start forming clusters. So by the end of the whole cluster forming thing, so what we can have is, we can have a setup like this. Okay, now from the calculating of distances and finding out which are the nearest, calculating the distances and finding out the clusters. So right now we have formed the three clusters. So in these three clusters you can see that the data is distributed and according to the distance we have calculated and it is fine. So the three random points are taken and the clusters have been calculated and that is fine right now. So this is one scenario where we can have this clustered. So this is the step 3 done. So we have clustered the data. So what is the step 4 is next thing. So step 4 will be calculating the mean values of these particular data. You need to calculate the mean values of data all the different data in the cluster. So you have these three blue color circles, green circles and red circles. You need to calculate nothing but the mean. So we'll calculate the mean and we need to reshift the cluster center. So this is not the cluster center actually. So the cluster center is somewhere around here. So I need to reshift the cluster center and that is how the algorithm works. So we chose the three random points. So after choosing the random points, we are able to make the cluster. So we made the cluster. So after making the clusters, what should we do now? So after making the clusters, we have a simple task that is nothing but we need to calculate the mean of each and every point in a cluster and then change the center of our cluster to our centroid. So what is the centroid is nothing but the mean of all these clusters. So the mean of all these individual data points will form a centroid. So this is nothing but a centroid of the cluster. So the centroid will look like this. So you can see here right now, so what has happened. So it is very clear from this particular example that we have changed our cluster center which was around here to the center. So actually speaking, technically the center should be on the same line. So since there is no space here, so I have drawn it above. So these are the cluster centers. So this is how actually the k-means clustering is working. But this is the case where we are forming the clusters and we are able to get the data. The last step of this is nothing but finding out the variance. So what is variance and how do you find out variance is pretty simple. So variance is nothing but telling you how the data is distributed. So what is the data that is getting distributed? So the data distribution we have our green colored circle. So then we have our blue colored circle. So that is my data distribution point number 2. So then I will have a red colored circle. So what is the thing that I will do is I will try to find out the variance. So what is the variance at the end? It is pretty simple. So if we want to find out the variance, so variance is nothing but how the data is distributed. So you can see here, out of all the data, my 3 datas are getting stored as nothing but 3 datas are getting stored as green colored circle. So that is part number 1. So then I have my 3 data that is getting stored as my blue color circle, that is number 2. So then I have 2 data that is getting stored as my red colored circle. So this is one kind of variation that I have. So in case of my situations where it is forming the right cluster, so then I can get the correct data. But as I told you, the points that I choose, that is nothing but the random points that I choose, need not be always right. So they might have other number of values. So we'll see a scenario where k is nothing but less than, okay, let k is equal to 3 only. We'll see another scenario. So what we'll do now is, so we have taken the same data now. So k is equal to 3 only, let the k value be 3. So what we'll do now is the next step number 2. Step number 2 is I'll choose 2 random points. So random point number 1 is around here. So let my random point number 1 be around here. So random point number 2, let it be around here. So let my random point number 2 be here. So then I have my random point number 3. So let my random point number 3 be here. So this is what will happen. So now what I'll do is I'll try to calculate the distances and find out how my data is actually getting varied. So okay. Before doing that, we'll make our steps a little bit more complicated. So this becomes an ideal scenario again. So what we can do is pretty simple. So what I'll do is I'll keep my random points quite further. Okay, I'll keep my random points quite further. So here I'll keep one blue colored circle. So this will make one random point. Another thing what I can do is I can have my red colored circle right around here. So I'll keep it at the edge. So this is one random point. So the next one is nothing but my green colored circle. So let my green colored circles be here. So this is the scenario what I have. So what we'll try to do next is we'll try to do the same thing. Form the clusters having these three as the random points. So this is how our data got shifted. So we have our four circles, four green circles forming in the green cluster, three blue circles forming in my blue cluster, and only one red circle forming in the red cluster because of how I choose the random points. So similarly, I need to shift my random points to somewhere around here. So that is how I shifted to my cluster center. So that is how my data is getting formed. So this is fine now. But the main problem that you need to understand is whenever I am forming a cluster using these random points, so I can consider my data distribution now. So what is my data distribution now is, so now you can see the distribution of values. So green colored circles, we have around 4 green colored circles. So that is our distribution right now. So after having 4 green colored circles, we have 4 blue colored circles. So that is fine, and only one red colored circle. So now the problem is, even though my taken in 3 clusters, the variance is not good. So what is variance? So variance is telling you how my data is getting distributed. So what is the case if my data is getting distributed? So very important to understand the variance. So this is how it keeps evolving. So the thing is, the 3 random points are not just one iteration. So every time there will be different random points taken. So then again clusters will be formed and cluster centers will be chosen. So after choosing the clusters and cluster centers, that is nothing but how cluster centers are changed. Mean of all these clustered points are taken, and the new mean is nothing but the cluster center. So that is how the cluster center is changed. So the thing is, after changing our cluster center and as well as taking in random points and shifting them, and the main thing we need to check here is the variance. So the variance forms a very important part. So what is variance telling you is, if I have my green colored circles, blue and red colored circles, the way the data is getting clustered. So for example, we have more values in our green and blue, but the way our data is getting clustered, that is our red colored point. So we have a very less thing. What is the important thing is, we have a very small distribution here. So if you can see around our data here, so we have a very small distribution. So that should not occur. But in our previous cases, what happened? So in our previous cases, our green values were around 3. So again, our blue values were around 3 and our red values were around 2. So this distribution was better when we compared to this. So here our data is getting concentrated only to our green cluster and blue cluster, but our red cluster doesn't have any value. It has only one value. So that is how you tell that which is the best random point that was chosen and which is the best cluster that is formed. So that is how you tell it. So it is all dependent on, every time there are hundreds of iterations happening. So at one time a random point might be taken here, second time here, a third time somewhere else. So each and every random point that is being chosen is like done for a number of iterations. So you can consider the number of iterations as n. So n can be 1000, n can be 10,000. So number of iterations are telling you which is your best random point that can be chosen to form the cluster. So the random point is nothing but the cluster center. So this is one method of doing it. So the next point comes in where you have the data, that is nothing but how to choose the value of k. So now I choose the value of k and I will be able to do some clustering here, but actually I want to understand how my k value is chosen. For this also the major important factor is variance. So what is variance? How my data is getting separated into different categories. So if I give some 100, if I give a basket of vegetables, so how my basket of vegetables, that is nothing but how my vegetables in my basket is getting separated. So that is telling you variance. If they are separated equally, that is nothing but if they are separated properly, so then the variance is fine. Otherwise the data has some issues, you need to choose the things properly. So that is one method. So this is the scenario where I have chosen k is equal to 1. So what happens in k is equal to 1? The variance will be very large because we have only just a green, we have just a pile of green circles. So everything should be clustered as green circles. So this is the problem. So how to choose the value of k is pretty simple. So whenever we choose the value of k, so we need to find out the variance. So what is the variance when I choose k is equal to 1? What is the variance when I choose k is equal to 2? And what is the variance when I choose k is equal to 3, 4, 5, 6 and 7? So after that I need to do some more important. So the method to find out the best value of k. So which is the best value of k to choose and how to choose the best value of k is done using a method called as elbow method. So what is an elbow method or how elbow method works is pretty simple. So what you need to do is so this is the values of k. So what is the thing that you need to do is you need to find out the variances. So what is variance? Again I'm clearly. So this elbow method helps us to find out the optimum value of k. So you know what is the variance. So variance is nothing but how data is getting distributed. So you are trying to find out the exact reason, that is nothing but. So you need to find out how many variations are there. That is nothing but how the data is getting distributed between these values of my green colored circles, blue colored circles as well as my red colored circle. So this is how I need to find out. So when I calculated my variance, so for different values, for example for k is equal to 1, so the variance was, the variance was quite low because the values were not optimally chosen. But whenever I went to the value of k is equal to 3, the variance changed suddenly, so there was a sudden change in the variance. But even after I chose my variance values of 4, 5 and 6, there were not such any great changes in the variance levels. So what I am able to tell is whenever my variance changes to a drastic value, so whether you are increasing or decreasing or whether you are whether you are keeping it more or keeping it less, using in an increasing scale or decreasing scale, what you need to understand is how your data is varying. So if there is any change in the particular variance value, so if your variance value is changing slightly, so that point is the perfect value of k. The point where your variance changes is the perfect value. So what you need to do, you need to plot your variance versus the k value. So at whichever point the variance changes drastically, so that point it is chosen as the best value of k. So that is the method called as elbow method. So variance is nothing but how data is getting distributed among the different clusters that is available. So this is how you are able to calculate the k values as well. Okay, the next question is whenever I have my data that is in an XY format, that is in a coordinate system, how would I differentiate the data? So if I have a format of data in my coordinate systems, it is not a straight line distance that I will be finding out. Instead of that, I have a Euclidean as well as my Manhattan distances that I told you in k nearest neighbor. So what is Euclidean distance and Manhattan distance? So as you can see here, the perpendicular and the base and you have the hypotenuse. So the hypotenuse is your Euclidean distance and your Manhattan distance is nothing but your sum of the sides of your perpendicular and base. So this is how we can calculate, or it is x2 minus x1 the whole square plus y2 minus y1 the whole square. Square root of that values will give you the Euclidean distance. So these two are important points when you are trying to calculate the distances. So you need to, if the data is in a xy coordinate system like a regular coordinate system, so the distances is calculated using your Euclidean and Manhattan distances. So you can see here, this is how each and every individual distance is calculated. Then again, the centroid is shifted towards the mean of all these points. So the cluster center changes after calculating all the distances, finding out their mean and forming the clusters. So this was the example of our k-means clustering theory. So you understood how k-means clustering works. Next, what we'll do is we'll do a practical program on to understand how k-means clustering is actually helping us form the important things. That is nothing but helping us cluster our data into different parts. So this is what we need to understand from this k-means clustering. So thank you guys, and we'll do the program in the upcoming sessions. Thank you.